Let's talk about how to use graphs to find limits. But before we go into the subject, there are two ideas I want to take note of. So I'll be using a graph to show you those two ideas. Let's see, this is our y-axis and this is our x-axis. So let's say we have a function on this graph and this is the function. The function is f of x and the function happens to have at an x value of 3, it corresponds to a y value of 2. The first idea I want to talk to you about is one-sided limits. One-sided limits are often written like this. The limits as x approaches a value, then you have a plus sign, or you have the limit as x approaches a value, you have a negative sign. So the plus sign simply means you are approaching the x value from a value that is greater than x. So if you notice, this is 3. The values greater than x are 4, 5, 6, 7, 8. And then this one means that you're approaching the x value from values lower than x. X is less than a value here. Here x is greater than the a value. Another thing I want to notice is that this one is called the right hand limit and this one is called the left hand limit. Let's look at this example and look at what our answer would be for the left hand limit and the right hand limit. So let's say we have the limits as x approaches, the key number we're looking at here is 3. So as x approaches 3 for the right hand limit of f of x. If you notice, as x is approaching 3, we are getting closer and closer to 2. The right hand limit here is equal to 2. Now, the left hand limit, that's limits as f of x approaches, as x approaches 3 of negative side is equal to, if we follow the graph, we notice that limits as x is getting closer and closer to 3 from the left hand side is still 2. So since we've talked about one-sided limits, let's talk about two-sided limits. A two-sided limit is often called a general limit. A two-sided limit exists when the left-sided limit is equal to the right-sided limit. So since we know that the left-hand side limit is equal to the right-hand side limit, that means that the limits as x approaches 3 on the right side of f of x is also equal to the limit as x approaches 3 from the left side of f of x. So this implies that the limits as x approaches 3 of f of x is still 2. Now, if these two limits are not equal to each other, this limit does not exist. So let's say we have a case where the left hand side limit does not equal to the right hand side limits. Then the limits as x approaches a of f of x does not exist. So we can use the abbreviation DNE, meaning does not exist. Let's look at examples for you to understand better. So we already have some examples lined up. The first example is find the limit as x approaches -6 from the left hand side. So if you follow this graph, as x approaches -6, as it gets closer and closer to -6, our y value is getting closer and closer to 0. So that means the limits from the left hand side. So the limits from the left hand side as x approaches 6 minus 6 is equal to 0. So for this second problem, we asked find the limits as x approaches -6 from the right hand side. So the limits as x approaches -6 from the right hand side Let's go back to our graph. So as x approaches -6 from the right hand side, the y value is getting closer and closer to 0. So this is equal to 0. Now you know what happens when the left hand side limit is equal to the right hand side limit. Then we have our two-sided limits. In this case, because the left hand side limit is equal to the right hand side limit, the answer is also equal to the two-sided limits. So the two-sided limits here is -6 and then f of x. Because this is equal to this same answer, we are going to use the same answer. So this answer is 0. Let's look at another example. So for the second set of examples, you're told to find the limit as x approaches -3 from the negative side. You can pause the video and try to solve this on yourself. Like we did before, we are going to be following the graph. We follow the graph from here. As we're getting closer and closer to -3, our y value is getting closer and closer to y. So that the limit as x approaches -3 from the negative side of f of x is equal to y. So this is -3 and this is -3. So you are told to find the limits of f of x as x approaches -3 from the positive side. So this is, if we follow the graph, as the value of x get closer and closer to 3 from the right hand side, we have our y value approaching 1. So that this limit is equal to, so here the limits as x approaches -3 on the positive side is equal to 1. For the last one, since we know that the left hand side limit is equal to the right hand side limit, this makes up our final limit. So that means the two-sided limit or the general limit is also the same answer as the left and right hand side limit. So that means this is equal to 1. Let's look at another example. For the first example, we have to find the left hand side limit as x approaches 0. As the x value is approaching 0, our y value is approaching 3. So that means the limits as x approaches 0 from the left hand side is equal to 3. For another example, let's say we have the limits as x approaches 0 from the positive side. For the second example, we are required to find the limit as x approaches 0 from the positive side or the right hand limit. So to find the right hand limit, let's go to the graph. So from the graph, as x is approaching 0 from the right hand side, we see that our value is getting closer and closer to a middle value between 3 and 1. So this is 2, by the way. So that means the limits of f of x as x is approaching 0 from the right hand side is equal to 2. Now, what is our general limit or two-sided limit? Now, if you notice, this limit as x is approaching 0 from the left hand side is not equal to the right hand side limit. So this is not equal to the limit as x approaches 0 from the right hand side. This simply means that the general limit or the two-sided limit does not exist. So here I'll write the limits as x approaches 0 of f of x does not exist. Let's look at another example. For the fourth example, we are asked to find the left-hand side limit of f of x as it approaches 3. So the left-hand side limit here as it approaches 3 is, if we trace our graph, this is going this way. As it gets closer and closer to 3, our y value gets closer and closer to 0. So that means we have the answer to this as equal to the limit as f of x approaches 3 from the negative side is equal to 0. For the second problem, we ask find the right hand side limit as x approaches 3. So you follow here, you follow slowly. So I get as the x value is getting closer and closer to 3, the y value is getting closer and closer to 0. So that means the limit here as x approaches 3 from the right hand side is equal to 0. For the general limit to exist, this has to be equal to this. Now since this is equal to this, that means the general limit is settled. The limit is as x approaches 3 of f of x, so f of x here, is equal to 0. Let's look at our last example. So for last example, if you ask find the left hand side limit of f of x as x approaches 6, we simply follow the same way we've been doing. So from the left hand side, if we are approaching 6, we are getting closer. The y value, we are getting further and further down the y value, but we never really approach 6, and our y value gets down like this, goes down, down, down. So this, anytime you see this kind of thing, it means that the y value is getting closer and closer to infinity. So that means in this case, the limits as x approaches 6, or the left hand side limit, is equal to, now the y value is reducing very, very fast, and it is going to negative infinity here. So that means the limit here is negative infinity. For the second question, we ask find the right hand side limit of f of x as it approaches 6. So this is the limits as x approaches 6 from the right hand side is equal to, if you trace the graph, we have as the x value from the right hand side gets closer and closer to 6, the y value increases so much, but it never gets to this dotted line. It never really reaches this dotted line. As it gets closer and closer to 6, we are seeing that y value is approaching positive infinity. So this is positive infinity. What about the general limits? If you look at this, the left hand side limit is negative infinity and the right hand side limit is positive infinity. So they are not equal to each other. So we can see the limits as x approaches 6 of f of x is equal to does not exist. So that's not find limits from graphs. If you like the video, leave a thumbs up, subscribe to the channel, then share with your friends. Thanks for watching.